Hi everybody. Since we didn't have class, I'm going to do a little example of how to do a power analysis, and I'm going to try to do one that's similar to what you have to do on your assignment. So I created a little example, and this is actually an example from the PowerPoint. So let's say we have a study where we have to find out if there is a difference in life satisfaction scores based on marital status, which is one of our independent variables, and as you can see it has 4 levels: married, single, divorced, or widowed. Gender, which is our second independent variable, male or female, and then SES, which is divided into low, medium, and high. And as on the assignment, you're already being told that you should go with the standard alpha level of 0.05 and your standard power level of 0.80. And then we're going to go with sort of a medium effect size of 0.25. So for each of these assignments, so you have to figure out how many independent variables do you have, which on the assignment I believe is already given to you. But so here what we have is 3. We have marital status, gender, and SES. Now we have to figure out how many groups we have. Well, we have 4 groups in the marital status, we have 2 different groups in gender, and we have 3 different groups in SES. So 4 plus 2 plus 3 is 9. So we have 9 groups. Now, if you were doing an ANOVA and there were any covariates, then we would include those as well. So now we have to calculate the degrees of freedom. And the degrees of freedom are calculated based on what Factorial ANOVA you are going to be running, if you're just doing the omnibus test, or if you want to be able to look at interactions and contribution of each independent variable, which we do. So what we have to find first is for each of the 3 variables, how many degrees of freedom do we have? So for marital status, we have 4 categories, and remember we always remove 1 degree of freedom, so 4 minus 1 is 3. Let me find my little equal sign, which doesn't seem to work. Hang on. Equals 3. Then for gender, actually let me put up here, I'm using this weird program, excuse me a minute. So let's say marital status right here. Excuse me, I have no idea what this computer program is doing, so we're just going to delete the whole thing. So marital status, as I'm typing with one hand on the wrong line and trying to hold my camera at the same time. Bear with me here. Alright, so marital. So again, we had 4 minus 1, which is 3. Then we have gender. So again, gender, we calculate degrees of freedom for that variable the same way, 2 minus 1, which equals 1. And then our last one is SES. So the main effect for SES, we have 3 levels, low, medium, and high SES, minus 1 degree of freedom equals 2. So these are our degrees of freedom for the main effects, but we also want to be able to look at interactions. So here we're going to start with the 2-way interactions. So we have marital by gender. And here what you do is you multiply the degrees of freedom for marital status and gender, which would be 3 times 1, and that is 3. And then we do marital status by SES. And here we have marital status, which is 3 degrees of freedom, times SES, which is 2 degrees of freedom, and so that is 6. And then we have Oh, I just realized I'm spelling marital wrong. I don't know why. Marital by gender by SES. So that will be 3 times 1 times 2, which also is 6. Oh, I'm missing one. Hang on. We are missing, let's see, gender by SES. Sorry. Gender by SES, which is gender is 1 and SES is 2, so that is 2. So now we add them all. So we have the main effects, marital, gender, and SES, which is 3 plus 1 plus 2, which is 6. Then we have 3 two-way interaction, marital by gender, marital by SES, and gender by SES, which is 3 plus 6 plus 2, which is 8, 11, plus the 6 we had right here, which is 17. And then we have the three-way interaction of marital by gender by SES. And so we add these 6 to the 17, and then we get 23. So our total degrees of freedom are 23. That's our numerator degree of freedom. And so now we go into the power analysis. And so what we already know is that we have to do a factorial ANOVA. And an ANOVA is an F-test. So we have to go down here. Let's see if I can put the camera a little closer so you can see. So we choose, in the test family, we choose F-test. And that's going to bring up different kinds. What we're doing is a regular ANOVA. And we want to do the fixed effects that include the main effects and the interactions. So that's the one that we put right here. The effect size we were told was 0.25, and so you can see that's sort of a medium effect. The alpha level of 0.05. The power we're going to change right here to 0.8 or 0.80. Then our numerator degrees of freedom, which we just calculated, is 23. And the number of groups that we calculated is, what did we say that was? 9. And so then, once you have filled out all of this, you go down here and click on Calculate. And ta-da! It's going to tell you that if you were to do that study with those 3 variables, gender, SES, and marital status, you will need a total of 372 participants. So that is how you do a power analysis. And again, if you have any questions about it, post it on the Q&A board. That way I can answer it, or one of your classmates can answer it. So just try to do your best on this assignment, and we will follow up and I will give you feedback on it.